you're looking at all right, so sound waves, let's look at those in particular. Type of wave sound wave is a longitudinal wave. So particles are going parallel to the way the wave is traveling. Source of any sound wave is any object that is vibrating. So a vibrating object is a source. And does sound require a medium? It absolutely does. So it takes molecules pushing on each other, bumping into each other to cause sound wave to happen. So it definitely requires a medium. Right. So process by which you hear something. This is pretty cool. So you've got, first off, you have to have a vibrating object, and it's pushing against air molecules, okay, creating a sound wave. And those air molecules are pushing against other air molecules, and this compression wave, this longitudinal wave, this pressure wave is traveling through the air at 343 meters a second until it reaches an eardrum, at which point your eardrum is vibrating back and forth, doing the pressure, like high pressure, low pressure, high pressure, low pressure. And that vibration is transferred into electrical signals, which your brain then interprets as sound. So it's pretty amazing procedure how we hear things. So how fast does air travel? I just mentioned that, alluded to that. It's 343 meters a second. That's 760 miles an hour, or Mach 1 if you've heard of that in terms of jets. So Mach 1 is speed of sound, Mach 2 is twice the speed of sound, Mach 3, 3 times the speed of sound. So what happens when the speed of sound travels through a liquid or a solid? It actually increases because the molecules are more densely packed together. So the disturbance passes along more quickly or more readily. So the speed of sound increases as you go through a solid or a liquid. So we hear a lot of different sounds. What is it that's causing a higher pitch? So higher pitch, lower pitch, that would be the frequency. You could also describe that in terms of wavelength. So the higher the pitch, higher the frequency, or the shorter the wavelength. What characteristics describe if something gets louder? You have a greater amplitude. So thinking about the wave that you learned in class, greater the amplitude, the greater the volume, greater the frequency, the higher the pitch. So interference. This happens when multiple waves overlap. So you get more than one wave overlapping in the same space. Causes interference. And superposition of a wave is the addition of the amplitude of overlapping waves. This is the resultant waveform. We'll demonstrate this in class. So constructive interference, this occurs when the amplitudes of overlapping waves are in the same direction, so that resulting waves has a greater amplitude. So you're adding up the waves. How do you find that? You add up the amplitudes of the waves together. Destructive interference happens when the overlapping waves go against each other. So it has the resultant wave has a lesser, smaller amplitude. How do you find that? Well, you would end up subtracting the amplitudes because they're going in opposite directions of the two waves. The natural frequency of an object, this is a totally different topic. So all objects have a natural frequency. All rigid objects have a natural frequency. So it's that frequency that object will most readily vibrate at. Forced vibration is when an object is forced to vibrate at any specific frequency. So that's anything. Combination of both of those is resonance, and that is when an object is forced to vibrate at its natural frequency. So it's forced to vibrate at that specific natural frequency. And resonance occurs, which we will talk about in class.